what we've already seen so far today, we've just been breaking down cube roots and square roots when they're not perfect, right? We're going to keep doing that, but I want us to consider things that are actually a little bit easier. Let's go back to something that we did the other day. We even did earlier today. What's the fourth root of x to the 20th? What's the easy thing to do when you've got exponents inside?
Divide.
Divide by what?
The index.
So 20 divided by 4 is just 5. Do you all agree?
Mm-hmm.
Another way of looking at this is if you take x to the 20th, if you were to expand that, you would have 20 factors of x, right? But then my question to you, if we look at it in terms of the factorization, how many sets of 4 would you have?
5.
You would have 5 sets of those. That's why you have 5 x's on the outside. Every 4 x's on the inside, and why do I need to look for 4 sets of x?
The index is 4.
The index is 4. Every 4 sets of x, I get 1 factor on the outside. But compare that to this example. I'm going to change it up a little bit. If I take the fourth root of x to the 21st, it doesn't work out very well, does it?
No.
Does 4 go into 21 evenly?
No.
But here's what you can do. How many sets of 4 would I have? If I have 21 x's, how many sets of 4 would you have?
5.
You would have 5 with, exactly right, you'd have 1 left over. Do you agree?
Yeah. Why did you need to put the 1 if that's already understood to be there?
For emphasis.
Oh.
I want to make it very clear to us that we see that we've got 20 and 1. We've got 21 factors of x. We haven't lost anybody.
Okay.
Now,
Now, why would we even
I did drop the index though.
multiplying it?
Why
After
what?
you add them, never mind, just kidding.
Now watch this.
Everything in there.
Watch this. If I look at it like this, if I had this guy right here, the fourth root and the fourth power are going to be kind of cancel each other out, right? So you'd be left with x to the what power? We would have x to the 5th, but then what about this guy? The fourth root of x, can I do anything with him? No. So he stays right here, like that. Here's another way of thinking about it, going back to how we use long division to reduce these guys and make it very easy. I have 21 factors of x. How many complete sets of 4 would I have?
5.
I would have 5 complete sets, right? But then what would I have left over? I've got 1 lonely guy, right? Does that make sense?
Mm-hmm. Yeah.
Now let's see if you can take that idea and expand it to this problem. The square root of x to the 7th. What is the index here?
2.
The understood index is 2.
X is cube root of x times the square root of
Whoops.
X to the 3rd.
X to the 3rd, right?
I'm sorry. X to the 3rd times
Square root
x.
of x, yeah.
Now check this out. If you have 7 factors of x, I'm looking for the square root, so I need to put these guys in pairs. How many pairs of x's would I have?
3.
I'd have 3 pairs, but then I've got 1 leftover guy, right? And think about what you're doing here. You're doing division of 2 going into 7. How many whole times? 3 with a remainder of 1. That's what we're doing here. Is that okay?
Yep.
All right.
Wait, on the other one, the 4 and the 4 cancel out the exponent and cancel the...
Yep.
But how come on the second example, the 3 and the 2 have
There's nothing to cancel.
Oh, wait.
This is an index here of 2. I didn't need to write that. I did it for emphasis because it's a square root. So here's the 2 is still there. So you're doing 7 divided by 2, 3 whole times with 1 left over. What if I have this? If I have the 7th root
Oh.
of x to the 45th. Make sure that you are writing this clearly so that you've got your nook and you've got your index.
X to the 6.
Say it without question marks. Remember, you're on the video.
X to the 6 with the radical of the x left over.
Not quite.
You got 3 left.
Oh, 3. Yes, that.
7 goes into 45 6 times,
Yeah.
and you have 3 left over. Do you agree?
Yes.
But what am I missing here?
Ouch, the 7, the index.
Index of 7. Now, students will ask me, do you need this multiplication symbol here?
No.
The answer is no. I put it there just so that we have a little bit of separation, so you can clearly see this is my exponent and that's my index. Because sometimes when we write too fast, we kind of smash things together, and it's very difficult to read.
And I was just about to say that, so you recommend that we should do that because I'm writing
Yeah.
it and it's looking like 2 numbers.
X to the 60.
Oh, when you write,
Yeah.
oh, well, so then you go like, is it x to the 67th, or is it x 67th root of?
So that's why you need.
But look at this. When I write this, is there any question about what those numbers mean?
No.
That's something that we all need to work on as students, is writing things clearly. Just like when you're writing a paper or even an email. Like in an email, does anybody know what IMA means? Yes, I don't know, okay.
Sounds like you're about to do something.
All right, I'm gonna give you another example.
You know what? I'm gonna just leave on that.
You keep making these idle threats. How about the square root of x to the 14th, y to the 23rd? Now wait a minute. Don't be scared. What was that?
7.
7 and 11.
Wait. I was going to write 7 and 11.
Oh, X to the 7.
Oh! X to the 7th with how many left over from the x's?
None.
No x's left over. What about the y's?
11.
2 goes into 23 11 times, but you have what? You've got 1 y left over, right? What if there had been x left over?
It would be XY.
It would have been inside the radical along with the y, right?
Mm-hmm.
Okay.